everyone, and welcome to today's presentation, The Evolution of Collaboration in Product Development. My name is Rachel Casciato, and I will be your moderator for today's panel discussion. Joining me today are two experts in the field of product development, engineering, and manufacturing, Jim Zwica and Nathan Hartman. Before we get started today, I have a few housekeeping items to go over. Everyone attending the session today is in listen-only mode, but we'd like to hear from you through the questions box in your control panel or by tweeting us at VertexVIS. We will be answering your questions at the end of the panel discussion today. And without further ado, I'm pleased to introduce you all to Jim and Nathan and tell you a bit about their background. Jim Zwica's experience in product lifecycle management and product development began in the 90s. Throughout his career, he has supported both OEMs and supplier organizations, helping companies understand how to best leverage their PLM tools and visualization capabilities throughout the extended enterprise. At Vertex Software, Jim helps support product initiatives. Nathan Hartman is the Dauch Family Professor of Advanced Manufacturing and Department Head of Computer Graphics Technology at Purdue University and Director of the Purdue University Product Lifecycle Management Center. Professor Hartman's research areas include the process and methodology for creating model-based definitions, examining the use of the model-based definition in the product lifecycle, and developing the model-based enterprise. Jim, Nathan, thank you guys so much for joining me today to talk about how collaboration has changed in product development.
Thanks for having us.
Thanks for having us.
Yeah, to start us off, I'd like to hear from the two of you based on your experience in this space back when you first started your careers. 20, 30 years ago, communication and collaboration in engineering, design, and manufacturing looked very different than it does today. So can you take a couple minutes and talk a little bit about what communication historically has looked like?
Well, Rachel, in many cases, information came to people in a serial fashion, meaning it was 1-to-1, maybe 2-to-1, 3-to-1 at the most. But we did not have the concurrent tools that we have today. We certainly didn't have as many of the digital tools as we have today, and we relied quite a bit on face-to-face, one-to-one human interaction. This often meant that we would have things that would have to be redone in order to communicate with others. And so we have a situation where the technology we have today gives us far more ability to communicate wider and faster than we had historically.
Yeah, I would agree. There's really no such thing, or it was in its infancy anyways, of version management or revision control. And so as Nate said, generally you had to walk up and say, hey, what's the latest thing that you're working on? And it was based on that communication that you would know that this is the thing I should be basing my design off of. So that certainly was a lack of structure back then, or in the beginnings of.
Because we tended to work in the same places as those people that we had to communicate with or that we needed to communicate with. And so, as Jim said, I could walk up, let's say, to Jim's desk and ask him what he was working on, and he could tell me. I could meet with other people in an organization or in an organization in which I would work, and we could do the same thing. And what that eventually led us to was that when you began to share information with each other, you began to trust that information because you knew the individual, you knew the context that the information was generated in. That said, we have a situation, though, that's what our tools allowed us to do at the time, right? And historically, human beings had done a number of communication mechanisms over the years, but if you look at that, the tools they use or the environments in which that communication happened, it was often in a one-to-one or a few-to-a-few type of a collaboration setting. And we didn't have technologies that would allow us to move information around the globe. It just didn't necessarily happen in the same way that it does today. And much of that communication medium over the years was very much a paper-based scenario. And that, of course, led to the speed or lack thereof that we had in communicating.
Yeah, even the 2D drawings, which were digital, that was relatively mature back then. But there wasn't necessarily an internet to support it. So you got DAT tapes, you got big stacks of floppy disks and things that were given to you and then you had to pull that off of that medium in order to look at it. So it wasn't just, oh, whoops, I forgot this, let me send it to you. No, that was a major logistical thing just to deliver it on the hardware, on the content that you needed on the medium. So it was interesting.
Mm-hmm. And obviously, we've talked about this a little bit already, but technology has really impacted how communication works today. We've talked a little bit about, you mentioned, how the internet has impacted things, and ideas of version control and revisions and things like that, how that impacts communication. So talk a little bit more about how in today's product development, a lot of computing technology, how that has impacted where we're at today.
Well, computing technologies in general, I think, have allowed us to communicate from one person, or the information that one person holds. They've allowed us to communicate much more widely in terms of an audience. They arguably allow us to communicate faster or even more accurately than we've done in the past. However, there are still some challenges with that, because it's also one way where you could arguably communicate inaccurate information much farther and faster than you might have in the past. But when you separate the technology from whatever the intent is to be communicated, people still have a desire when they're working in a design or a production or a supply chain sort of environment. They still have the desire to communicate, in many cases, the same kinds of information that they needed to communicate in the past. The difference being today is that, number one, their tools allow them to move that information faster. As Jim mentioned before, there's this ability now to redo certain kinds of things if whatever they create isn't correct the first time around. But secondly, they allow for a much wider distribution mechanism and a much more controlled distribution mechanism than we used to have in the past.
Yeah, and even with the tools being more powerful, the humans tend to not react in a way that just automatically gives you efficient, nicely structured information flow. So the tools can be very powerful, but are we utilizing the tools to their utmost ability? And so as these stuff came online, I'm reminded of Richard Feynman, when an old physicist during the Manhattan Project. That's the first time they really had computers. And he said all of the engineers were like playing with it in a way. They were computing sine tables and stuff like that. They were doing things that they already had. There was no reason to do that. And so even back then, they were essentially playing with it. He even called it a disease. He said they're wasting their time on these tools. They're not using them in new, efficient ways. They're not rethinking how they can utilize these tools to better communicate. And so that is just human nature, I think. And it just, every wave of new technology that comes in, it's the same thing. So now what? How do you do this better now based on the tools that exist?
Because I think when you separate, as I mentioned before, when you separate the intended outcome of the communication from the technology medium that we use to often conduct the communication, when you separate those two things apart, what human beings are trying to share with each other is still, in many cases, the same sorts of information and the same sorts of outcomes that they would have shared in the past when we were making 2D drawings on paper, or we were typing memos with a typewriter, or when we were doing calculations by hand. It is often the same kind of an outcome. What these digital information processing tools that we have, whether it be in the engineering or manufacturing space, or even in, say, a space that's not related to this at all, like healthcare, what this gives us is a faster, arguably, understanding of information, a faster medium by which to communicate, which hopefully lets us get to decision points much faster and hopefully more accurately than we may have in the past.
Yeah, I agree. But also you have a mature workforce that they've had success doing things the way information was delivered to them in the past. These tools could give them a new opportunity, but it could put them out of their comfort zone. look, I get that I could get it this way. However, I have 15 years of doing this and I'm really good at doing it this way. So you have to kind of change their mindset and entice them to go to the new technology to show them and get them convinced that they're going to succeed with this new method.
Yeah, absolutely. And I believe that we're going to talk about that a little bit more as we continue the conversation and thinking about, some of the different, obviously we've talked a lot about technology, we've talked about intent, and part of this also is just these digital concepts that are coming up in today's industry. We hear a lot of buzz about things like the digital thread, the digital twin, and other types of digital concepts. So how do ideas and concepts and these types of things kind of come into collaboration today?
I think, Rachel, from my perspective, one of the things that's important to remember about some of these terms, such as digital twin and digital thread, is that in many respects, again, what we're trying to get to in a product design or manufacturing environment has in many cases to do with the information, the decision making, the accuracy around the environment and the things that are in it. And when we think about using this concept of the digital twin, for all of the hype that surrounds that term today, much of what we're trying to accomplish with the digital twin is about decision making. It is about having accurate information in the right place at the right time. That desire has not changed at all. I think for many people, regardless of whether they were using paper to communicate or even if they were using disconnected functional areas in their organization to communicate, the desire to make better decisions in a more timely fashion is still there in many cases, regardless of the tools that we use. And one of the things that is critical about this idea, though, of the digital twin is even in today's modern age of computing and all of the computing capability and capacity that we have at our disposal, the information thread that underlies that concept of the digital thread is still in many ways disconnected and discontinuous. And that's simply just where our technology is today. And so as technology evolves, we'll eventually begin to see that thread of information become more continuous. We'll begin to see that digital twin become more accurate.
Yeah, I agree. And I think in a way, digital twin, digital thread is just, they've put together a couple phrases that click. It's easy to understand. If you ask someone who hasn't spent time in this space what a digital twin is, they could probably get pretty close. But really, I agree with Nate that it's just an encapsulation or an overarching term that applies to all the things that we've been trying to do since the 90s with the digitization of this information during the, say, an engineering design process. It's easy, you just get it faster for some reason with those phrases versus what we've been saying before. But again, I agree with Nate in that while there's been a lot of tools that have made things a lot better for individual pockets of people, if you look across an entire enterprise or a supply chain, there's a ton of administrative manual effort that is not continuous with what we would prefer, but it's still better than what we had in the past.
So to build on that a little bit, Jim, I think when you think about what the artifacts were that we used to communicate, 2D technical drawings historically formed the backbone in many cases of how people would communicate in a design or manufacturing or supply chain environment. Those were representations that human beings could understand, and they were very descriptive about what a product was or a process was that made that product. And one of the things that it's not removed in a digital environment, but in some cases it becomes hidden by the form that digital information takes, and it takes a certain amount of knowledge, a certain amount of background, a certain amount of skill to be able to interrogate that digital information to get out of it the kinds of things that people were historically used to being able to simply see right on the surface when they used drawings as a way to communicate. And when you think about that structure that was used to communicate. We might create technical drawings in a way that was done with, ink on vellum or ink on mylar, and we would use, reproduction technologies to make copies of those, sort of like, an old copy machine might do in that fashion. But the idea that we had embedded information, if you will, in that drawing was not a new thing to people. And once you were familiar with how those drawings were made in a particular company's environment or a particular organization's environment, you could very easily read what was there and get the information that you needed. But in this particular, and by the way, two-dimensional drawings on paper, you were at sort of your lowest common denominator, so to speak. Mm-hmm. It was you really couldn't go any lower than, say, ink on paper, or you couldn't become more basic than a copy of that. However, with computing environments today and the infrastructure that goes with them, servers, databases, viewing devices, and the information that goes along with them to create that thread, because that digital thread is made up of not just the information, but the infrastructure and the architecture used to create it and to disseminate it and to view it. Mm-hmm. And so that is a point of entry, so to speak, into the digital thread that people have to be able to get past in order to have the same level of usefulness for that information that they would have had with a drawing.
Yeah, and if you broaden it up to enterprise-wide, so think of it something simple like a procurement person who wants to know how much steel I should be buying for this design. What Nate just said, they may have to go to the engineering-centric collection and classification of information, pull the drawing, go look at that table, and in this corner of the table, you're going to see this is the material and it's steel or iron or whatever. And that's how they would have to go and sift through all of those drawings, go to that exact same spot and find it. So back then, that was their way to do it. Today, that should be easily harvestable for not just the engineering world, but across the enterprise. For what information do they need to see in their context in order to make the right decisions, whether it's purchasing or engineering changes, that sort of thing.
And so historically, as people began to learn how to read those drawings and get that information, companies would develop volumes and volumes of documentation that would, or even standard documentation that would go along with their products, and they would spend a certain amount of time and effort and finances to keep that archive, if you will, up to date. Today, while we still spend time and effort and money to keep an archive up to date, the ability to have a more centralized source of information, to have a maybe more singular in the past than a source of information, although I'm not so sure that all companies are able to get to that one individual singular source, but I would simply say we've reduced, hopefully, the amount of sources we have of information in a way that allows people a more timely and a more confident way to access information, whereas in the past many people would have their own versions of that same sort of archive. They would have their own versions of the information, and the problem with that was you had some individual's own interpretation of the product information rather than what the true elements of the product information were. Mm-hmm. And arguably, with the computing environments we have today, we have a much cleaner way to communicate a more singular source of information about products and processes than we may have had in the past. We also have the ability to use 3D modeling tools, 3D visualization tools that allow for a much more natural and naturalistic view of a product and viewing information in context rather than looking at two-dimensional orthographic drawings that is not the way human beings tend to look at the world.
No, I agree. Yeah, I mean, it's, and I think it also opens the thread. If you look at the digital thread, there's a structuring of information that's important, but if engineering hands something off to manufacturing, and they kind of alluded to the sort of the institutional knowledge that maybe the 30-year person on the floor, he says, yeah, engineering always gets that wrong. We do it this way because of it's more reasonable or it's easier to do. But that packet of information may have historically never made it back to engineering, because had they known, they said, okay, fine, we'll do it this way. But the thread, in theory, should allow or enable the collection of that information that should be decimated everywhere else for everyone to be able to see and make things better. That's been historically hard. And so it's possible that this thread should enable that to be, we can capture that information and get it to where it needs to be done so improvements can be made.
Because historically that communication was often one way. It was communicated out from a design or other authoritative source, and it was communicated outward to the rest of the organization without a great deal of feedback, or at least without a good and timely way to return that feedback. And that's one of the other things that this idea of a digital twin and a digital thread hopefully get us, is a feedback loop.
Right.
A more intact feedback loop.
It's not so disruptive to getting their job done.
It's actually a really good segue. We've spent a lot of time talking about, kind of the differences in historic versus what it looks like today in terms of collaboration processes, communication styles, and that sort of is starting to shift into obviously more 3D modeling and communications. So we started talking about this a little bit already, but I want to dive into it just a little bit more about why digital 3D models are such a powerful communications media today.
Well, I think when you look historically at the human capacity to create and design, right, over the centuries, human beings made artifacts, they made tools, or they made structures because that's what allowed them to fulfill this need in their condition or in their time. And the medium of communication, they really only had a few different choices. One was verbal, obviously, and we all know how to talk to each other and communicate verbally. But when you try to explain or document a complex object or a complex process, human language often breaks down very quickly in terms of the kind of information and the originator or the author can share, but also on the receiving end of that communication, it begins to overwhelm, the human capacity to process information. Creating visual representations of objects or structures or diagrams of processes over the years has been a much more effective way for most people to be able to communicate. And so when you think about where the process was decades or even centuries ago, when people began to create mechanical artifacts, mechanical objects to do everything from lift bricks in the creation of a cathedral to moving water around their communities or other things, the idea was they wanted to be able to document that product. And so they began to draw, they began to sketch, they began to paint, all of which was done on a two-dimensional medium, right? Paper or something like it. And the challenge they had was being able to depict that object or that mechanism realistically. And so in what we ended up having in many cases was these creations, these evolutions of how they communicated. When you think about the way most designers or engineers learn how to do visual types of communications, there's usually some form of sketching or two-dimensional drawing or two-dimensional orthographic representations that they create. Well, much of that historically was based on the fact that the tools for designing, creating, and documenting that we had at our disposal were not the same size or scale of the objects that they were making. And so human beings had to find a way to get accurate, scalar information into a form that they could share. Well, we don't have to worry about scale in digital environments today as much as we did, obviously, in the past.
Mm-hmm. Yeah, you're making me think of some funny things where scaling issues become a problem, whether it's trying to land something on Mars, where one part of that was in inches, the other part was in millimeters, and then the entire mission failed. But yeah, I agree with the standardization of communication, especially when you're building things. And I would imagine even back, as far back as time goes, it wasn't always the same people that you're talking to that were doing the entire project. You may have to order something that was going to be supplied to you, that was going to facilitate the assembly of something. And unless you communicate exactly to them what needs to be done, then you're going to have problems. And so we're talking 2D specifically, and the standardization of that information. 3D, human beings tend to look in 3D or visualize in 3D. But that's generally not enough. You see that drawing, but then you need to see context, you need to see dimensions and standards and requirements, that sort of thing, to know that you're building it the correct way. And I think that's just how things have evolved over time. But humans look like the 3D side, but then they always need 2D to support today.
And that the standardization of that two-dimensional drawing or drafting process, as it was often called in a design and manufacturing environment, to Jim's point, you evolved over time. We have standards that tell us where notation should go or where dimensional information should go. We have standards that talk about the 6 principal orthographic projected views of an object, and all of that was standardized to some degree over the years and over the decades and over the centuries, because human beings needed a reliable way to communicate with people who might have been outside their most immediate working group. And the challenge, though, with that is that because they were dealing with often paper-based media, the idea of looking at a top and a front and a side view of something with notes and dimensions on it, certainly not the natural way human beings look at the world, right? We have binocular vision, we see things in 3 dimensions. And so when computer-aided design tools came along and we were able to begin making 3-dimensional representations of the object, even though obviously a computer screen is a 2-dimensional medium also, but the idea is that we're able to give to the viewer the perception of 3 dimensions. And so it was a much more natural, more readily identifiable way to communicate with someone. And that's really where the power of 3-dimensional modeling and the associated visualizations that go along with it, that's really where the power from a communications perspective comes from, is it more readily matches the human being's ability to see and understand our world.
Yeah, and then the other part of it is, we've been talking about end state here, but usually when designs are new designs, the next car, the next whatever, they look at the old stuff and then they modify the old 3D geometry to adjust to the new design. And so when you're creating something new, you tend to want to start with clay that's already been sort of molded close to that, and then you modify that to the new spec. Then you have the drawings and everything and the PMI, which is aligned now to 3D more and more for a model-based definition. But really, to me, I think the power of the 3D is when you're changing it and you're going to the next thing, because that helps them sort of hit the ground running versus starting something from a 2D perspective.
And when we communicate amongst the people in our design or manufacturing groups, the ability to communicate, as Jim said, that that initial stage or that starting point, and then create the next iteration of the product or whatever, the structure or whatever it is that you're creating, the ability to build off of what came before is also another more unique capability to a digital environment than it was a paper-based environment. And while we could certainly build off of previous iterations of a product in a paper-based environment, because much of that was drawn by hand historically, and then when we had two-dimensional computer-aided design systems, we had the ability to copy those files. But even then, there was a great deal of manual manipulation of that existing artifact that had to take place in order to be able to reuse that effectively for a design or a manufacturing situation. And I think the argument can be made today that in some respects, being able to manipulate an existing three-dimensional data set, whether it be for design or just for additional visualization options, often can happen faster and potentially more accurately than it did in the past.
Great. So we've started, as we've been talking about this, you've started to just lightly touch on some of the challenges with 2D versus 3D. Jim, you mentioned that individuals who've been doing this 10, 15 years, they don't want to change, or they're comfortable in their processes. They might not want to implement some of these other more 3D model-based things. Nate, you've mentioned a couple of other things very similar to that. So talking about, a little bit of how people can be kind of stuck in this 2D mind frame. What are some challenges with this 2D versus 3D mindset?
Well, I think one of the things, and Jim, you were alluding to this earlier, but one of the things that people who have gone through a large portion of their career using two-dimensional drawing media, I think often experience is that I mentioned before that two-dimensional media, especially if one was to print a drawing and get it onto paper, or if you're using an older drawing that was literally drawn by hand on paper, we've never had to worry about version 2.0 of paper. That was never a problem. However, in a digital environment, we have to be concerned about software changes all the time. And when a software version changes, there's always some amount of concern about whether or not my digital product and process data that go along with any particular version of software continue to remain intact and continue to remain accessible. We didn't have to worry about that as much with paper. Now, obviously, paper or mylar or vellum, all of those things can deteriorate in a physical form over time, but we also had the ability to copy and replicate and reproduce those things such that we could save them in perpetuity. Well, one of the things that happens in a digital environment is that when I want to exchange model-based information or 3D-based information amongst different authoring systems or amongst different users, I risk losing information. I risk, as part of that translation process, if there was ever a time when that old phrase of lost in translation was any more true, it would be in this instance, is when we move digital information around. And so, Jim began to mention PMI, product manufacturing information. These are, generally speaking, PMI is all of that associated dimensional information, textual information, notation information, other symbols. Historically, we would have put those on a drawing and they would have been attached to the different views of the object in the drawing. In a model, we can add those same things, but because, for example, something as simple as the viewing direction or the viewing plane relative to the computer user may be at a different angle. It may not be parallel to the screen. Thus, making those annotations difficult to read. There's often not, default placement of certain kinds of annotations in three-dimensional space. And so you end up having some of those annotations and symbols and dimensions overlapping each other. And so sometimes, even though the geometric definition of the object is much easier to understand, sometimes the textual information that accompanies it is not as easy to understand in a three-dimensional environment as it was in a 2D environment.
Yeah, and you're touching on the consumption mechanisms. If you think back, the file formats are not always backward compatible. So as you go 3 or 4 years ahead, it's possible that that file is not even open. You can't even open it in the new tool today. And I remember that being a problem back in the 90s, where we would actually just encapsulate all of this, all the binaries that we use to actually open this content. Since we knew we couldn't trust that maybe in 5 years you would be able to open it again, we had to capture everything. And so even if it's done perfectly, like Nate's talking about model views and PMI, making sure that that's perfectly aligned, can you guarantee that in 5 years you're going to be able to open that same content in the tools of today? And then even more broadly, if you think about automotive, I think they're on the hook for 40 years of, if they roll out a car, they have to keep all of the information that they used to create that car for about 40 years. So I'm talking 5 years. Fast forward 40 years. What do you use to open that file? And so that's, I think, often why they go, well, we don't know, but let's just bail out here and take the thing that we know will be around, and that might be a paper copy or something, so that we know that in 39 years, if we have to defend this car, that we can at least pull out all the content and not lose anything.
Aerospace is another industry sector where Federal Aviation Administration requires them to keep digital data for 50 years or more. Well, who knows what our digital authoring and consuming platforms are going to look like 50 years from now. Yet many airplanes that are designed today are meant to fly and be in service for at least that long, if not longer. And so what we end up having is this human tendency, I think, to revert back to what we know. So when there is a challenge or a problem around time or accessibility or accuracy of information, human beings often tend to revert back to what they know. And in many instances, we're in this time where there's sort of a hybrid workforce in place. There are people who have been in the workforce for comparatively speaking, a longer period of time, where they, for major parts of their career, have seen the evolution, have seen the transition from paper-based communications to two-dimensional CAD to now 3D CAD types of data, whereas there are, on the other end of the spectrum in the workforce, there are people who have been in the workforce now, say 5 years or less, who don't historically have the benefit of having used or created paper-based drawings for product design or for manufacturing. All they know is the ability to create digital, and in most cases, three-dimensional representations of objects. Yet they have a challenge at times reverting back to a paper-based method or a paper-based mechanism of communication, because it's just incongruent with what they know. And so, human beings, being creatures of habit in many cases, will simply revert to what they know, whether that is two-dimensional mechanisms or three-dimensional mechanisms. And that's one of the things that makes kind of that cultural change, that cultural shift, a challenge.
Yeah, and I also think if you look at the tools a little bit, historically you've relied on the client or the client device to be able to interpret what's been given to it. Here's this blob of binary content. Boy, I sure hope on your computer or on your device that it's got a piece of software that can then convert it into something that you can read. So I think we're on this journey where ultimately, as opposed to having software on your device, you more likely will be in a platform that you don't even know. I mean, maybe this CAD software is 15 years old, but on the platform, we're able to handle that and let's just deliver you the result versus relying you on having something that you can do on your own. And that may eliminate some of this aversion to going MBD, is because you don't need to make sure you have the latest, greatest, or that software on your device to interpret it, but the platform will handle that for you and just deliver you what you need to know, and that's the information in your context.
Yeah, so Jim, to build on that point is we exist in this technological environment today where the authoring tools used to create three-dimensional models for design or manufacturing are generally not the same as the viewing tools or the consuming tools that someone might use who needs that model. And so from a design perspective, I'll just use that term design very broadly, but from a design perspective, we tend to use computer-aided design tools to create these geometric representations of an object, to notate those or dimension or to add symbols and what have you to them. But when that gets communicated to someone else, let's say a manufacturing engineer or a service engineer or procurement specialist or even someone in marketing, they're not likely to have that same computer-aided design tool as part of the software at their station, or let alone on a let's say a mobile platform that they might use in some cases to view that information. And so, Jim, to your point, one of the challenges with the digital thread concept today is that thread is somewhat disconnected. And while some people may advocate for the idea of standardizing or what have you across one particular software vendor's tool sets and platforms, that's not always the easiest thing to do. That's not always the most practical thing to do. Sometimes it's not the most cost-effective thing to do. And even then, let's say you overcome all three of those parameters, you may not always have that unbroken connectivity, even in software tools that come from the same software company, due to mergers and acquisitions and other things. So existing in our environment today to do product design and manufacturing is one of those things that you will have to deal with, is this idea that the authoring tools and the consumption tools for this three-dimensional information don't always use the same formats in order to move information, thus making some discontinuities in that digital thread.
Anything else to add, Jim?
No, I agree with all of this. I think we're in flux. We're heading the right direction. It'll ultimately get there, and it'll just come down to, as Nate said, the creation tools and the consumption tools won't necessarily be one-to-one anymore, but they'll be more one-to-many.
Great. Well, thank you guys very much for walking through all of that today. I think that, in summary, there's a lot that we can pull away from. To summarize what we talked about today, historically, product development was this serial face-to-face conversation, generally with people that you all worked with in the same company, the same building, and you had a lot of trust in each other, and everything was very much based in 2D. As things have changed a little bit and evolved, engineers today still need the same information, but the way it's delivered and communicated has changed really, really dramatically. And there are concepts that are virtual and digital, such as the digital twin, digital thread, and things like that, that are really enabling collaboration quite a bit. They're allowing this to happen. However, the tools need to be utilized to their fullest extent. And that would help with things like feedback loop and things like that, and help organizations get to decisions faster and be able to do things better. 3D models are a much stronger way to communicate design intent, but there is still a really big challenge in 2D versus 3D. We spent a lot of time talking about challenges both on an individual human level and within an organization, different expectations that people have and different compliances that organizations need to make sure that they are still in compliance. compliance. And to wrap some things up, we did get a few questions from our audience based on the conversation today. The first question I have here is, I find that manufacturing and assembly needs 2D drawings, so I still have to create them anyway. Because of this, my design team still works mostly in 2D, even though some of us want to move into 3D. Any ideas for how to help manufacturing and design kind of work more closely?
Well, I think from my perspective, I think one of the big challenges in a situation like that to be overcome is this a challenge around the infrastructure to move the information, or is it a challenge around the mindset of the individuals who are in that situation, whether it be design or manufacturing or both? You know, there is a rather straightforward solution when it comes to the infrastructure, the computing infrastructure, the authoring and consuming systems for information. You can pick various vendors' tools to both on the design side and the production side to get information where you need it to go. The bigger challenge to deal with right there is a mindset change. You know, over the years, we've all heard the tales of how, you know, the people in the design role don't necessarily get along with people in the manufacturing role, and vice versa. It always seems as if, you know, design creates something rather elegant, yet manufacturing has trouble making it. Or, you know, manufacturing says they can't do this for whatever reason, and design questions them as to, well, gee, it's just not that hard. Why can't you do it? Well, you know, that being said, what I think further compounds some of those historical communications issues is this, again, this reversion people have to going back to what they know best when there is a pressure-filled situation, such as meeting a deadline or meeting a quality metric or something like that you might have to do in production. And so, you know, making sure people are trained on the use of the tools, as well as trained on the use of the information, making sure that people can understand the benefits as well as the costs related to their particular job role. As with many things, transparency in this situation of the costs and the benefits and of the information is particularly important.
Yeah, I was going to head that way too. If the challenge here is the return on investment, or trying to defend the management, why going to 3D would be better. It's if you have a 2D drawing and there's a design change, you have to modify the drawing in more than one drawing probably to reflect that change. But if you have a 3D model, you just bring up that model, you do your radius changes or fillets or do your dimensional changes, and then generate the 2D drawings off of that. I agree, it is a little bit of a weird world where you have a 3D model that is the master, but then the 2D drawings, which are the children, become the master based on external views. So then if you focus on that, then they say, well, why are we doing the 3D if these 2D drawings are the master? But it's all in your ability to react and change things quickly and then generate the new masters, you know, in a nice, efficient way. So yeah, I don't know if it's a cost thing that they're having trouble with, but at the end of the day, it's a more efficient way to work to generate the 2D drawings, I would say.
Well, and I'll just add one more thing to that. Over the years, as computer-aided design tools and the data they create have become more prevalent, you know, one of the proposed or suggested returns on that investment is that you create this artifact once or in one place, this three-dimensional model, and it is used many times by other people in the product design and manufacturing process. And so many companies want to try to realize that return on investment. However, just like in a two-dimensional CAD or even a two-dimensional hand drawing environment, you still have to have well-defined processes, well-articulated processes, well-understood processes well-followed processes in order for that three-dimensional data to be as good or arguably and hopefully better than the two-dimensional environment. Without that, somebody could make the argument that people are just simply creating three-dimensional digital junk and distributing that to other people in the organization.
Great. Next question we have here is, ideas like the digital twin help us do more work up front in the process. We found that it can really cut down on our design cycles. How have you seen this in other companies?
Well, I think from my perspective, the digital twin, while I think there are some notional elements that are well accepted to its definition, a digital twin will mean different things to different companies in different economic sectors or different industry verticals. And I think from that perspective, I think one of the things that we need to be cognizant of with respect to the digital twin is that it is often a collection of pieces of information or of software and hardware computing tools that are coming together to represent the object, whatever that is, whether it's a computer mouse or it's an airplane or something in between in terms of complexity. It's a collection of a number of things, and we have to get all of those sub-elements connected together in a way that allows it to be useful, because the most critical piece of that digital twin functionality is the feedback loop back to the physical object.
Yeah, and what I've seen also, and it's a little bit of more of a challenging conversation, is the engineering team may be asked to do more to enable other parts of the company, other people who are on that thread. And then it becomes a challenge because they're not getting their own benefits. Say, hey, all right, you're asking me to put 5% more of my engineer's time to classify this or to add content to it, or even structure the data in a way that would be usable throughout the rest of the enterprise, but they're not the ones actually benefiting from it. So it becomes, in a way, they have to understand what it's enabling, how it's empowering others, and that ultimately they will benefit, but maybe not from the initial curve value of it to help them, but it greatly enhances the rest of the enterprise to be able to get access to this information that's traditionally been a more of a challenge to get. And so that's where I see a lot of the conversations is that, hey, sorry, we need you guys to do this, but boy, those teams over there are going to really be happy when you do it. And so those are the conversations that I see that are a challenge. But then ultimately, after they've done it and they see that not only do those other teams get the value, but those phone calls asking you to do that special favor are tending to get dropping in frequency as well. And so ultimately everyone benefits, but you do have the initial challenge of this new work as they see it sometimes.
And Jim, I would just simply further build on that and say that this is where managerial and executive support really becomes critical, because again, you may be asking people to do either more or different things than they've done in the past, but what that enables the organization or the group to do in a much larger fashion is well worth that investment.
Great. And last question here for today is, since mindset is such a critical part in collaboration, how do you address cultural change? It's a big question, and we've touched on it a little bit.
Well, from my experience, Rachel, it's been again, you want to have as well-defined processes as you can. You want to have as complete and well-supported of a technology tool set as you can. And I think the biggest thing from my experience has been starting off with a reasonable and manageable sized and scoped project that you can demonstrate the value to the stakeholders, you can demonstrate the process of implementation through to completion, and hopefully you can demonstrate some initial quick wins or return on investment, or capture that proverbial low-hanging fruit, whatever metric you decide to put on it as an organization, that you would be able to realize those.
Yeah, I think it's a mix of a lot of things. It could start with the tools being written in a way that actually enables you to capture this in a more efficient manner, versus you don't want, if you're in the flow of doing your job, you don't want to have to stop, go over here, do this thing, then go back. That's really disruptive, which tends to lead towards them, all of that side work piling up, and maybe they do it at the end of the day or the end of the week. So if you want tools that will work in a way that works, that helps make that process easier. You also want to we've talked about this a little bit, but an enticement, you want the tool, or you want the process, or you want the extra work to be enticing to do, because they themselves know they're going to get value, or the enterprise for the broader good are going to get value out of it. And then also you need senior level buy-in too. I mean, there's just a little bit of everything here. Whereas, look, we realize this feels like a challenge. I do remember back in the day rolling out the first digital prototype process at Ford. Every engineer hated the idea of their content being made public to everyone every day, because they were worried, it's not perfect yet, I don't want anyone to see it. But then, would you like to see everyone else's stuff every day? Oh, absolutely. And so, within a week of us rolling out the very first representations of their digital prototyping process, all of those complaints went away, because everyone saw the value of having everyone's stuff there immediately. And it also helped, by the way, if you're walking through the lunch line and someone's part was a little bit goofy and you noticed it, you would just say, hey, what'd you do to that? I see your part's a little bit, it's screwed up today. Guess what? That fixed it, and they're able to do some things, so that transparency was very good. So the culture thing is tough, but it's all a little bit of things contributing towards the right direction, and then ultimately it gets there.
Great. I think that's all the time that we have for questions today. If we didn't get to your question, we will follow up with you directly. The panel discussion today will be available on demand, and we will send out the link to everybody who joined the conversation today, and you'll see that come from us tomorrow. The good news is that we're just getting started talking about collaboration in product development. Coming in the next couple of weeks here, Jim and Nathan will be returning for another panel discussion called An OEM's Transformation to a Model-Based Enterprise. We will continue the conversation of 3D collaboration as we discuss how model-based approaches and transformations in our industry. We encourage everyone to return for that and keep an eye out for details coming out shortly. Thank you all for joining us, and have a wonderful rest of your day.